All right, chemistry class, we are going to look at another lab today here. And this one is going to deal with acids and bases and different indicators. And we'll learn about those today as we walk through this lab together. So in this lab, what we're going to do is we're going to take several different substances and we're going to test them using what are called indicators. Now, an indicator is simply a chemical that is going to change colors depending on whether the substance you're testing is more acidic or more basic. Meaning, if it's acidic, it has a higher concentration of the hydronium ion, and we'll talk about that in class. If it's basic, it's going to have a higher concentration of the hydroxide ion. Okay? So these chemicals are going to turn colors. They're going to react and turn colors based upon whether you have more acidic or a more basic solution or substance. So in this lab, what we're going to do is we're going to take a number of different substances. As you can see, hydrochloric acid, the formula for that is HCl. Sodium hydroxide, that is NaOH. Ammonium hydroxide is NH4OH. And then some dish detergent, some isopropyl alcohol, some plain water, just distilled water, pure water, acetic acid, that's another type of acid. The formula for that is HCH3COO, I believe. And then sodium bicarbonate. Sodium bicarbonate, the formula for that is NaHCO3. Okay? NaHCO3. And we're going to take these, how many we got here? 1, 2, 3, 4, 5, 6, 7, 8. 8 different solutions, substances, and we're going to test each of these with different indicators. And we'll talk about what these indicators do and what color they might turn based upon whether these are acids or bases. So we're going to test it with what's called red litmus paper. It's paper that is coated with a chemical. It's red and it's going to turn blue if the substance is more basic. Here we have blue litmus paper. Again, it's a piece of paper coated with a chemical, and it's going to turn red if it is more acidic. Phenolphthalein, methyl orange, bromothymol blue, and phenol red. Those are 4 indicators that are going to be in solution form, and you'll see how they turn colors. Okay, so this lab is done. It's very colorful. I did it, and then I'm going to just share a picture with you and show you the results of this particular test here, where I took the 8 different substances and test them with those different indicators, and then we'll record the results, what colors the indicators turned out to be. So let's look at the results. Okay, now that we've looked at the results and the photo that I showed you that shows you the different indicators and what colors they turned, let's write in what we saw. Okay, so with the red litmus paper, hydrochloric acid turned red. It just stayed red, I should say that. The blue litmus paper actually turned red. Okay, so that's an indication that it is more acidic. Okay, we're going to just make a little note here. This must be an acid. S is clear by the name. Phenolphthalein was, I believe it was somewhat colorless. Okay. With the methyl orange, the hydrochloric acid was kind of a red-orange color. The bromothymol blue, the hydrochloric acid was yellow. And then this was orange. Okay? And we'll talk about what those colors mean as far as how acidic or how basic something is. For the sodium hydroxide, it was blue, the red, and of course this stayed blue then. This was pink. We have orange, blue. We're just writing these in because we want to refer to these in a little bit and try to figure out what these indicators tell us, okay? And then red. Here, the sodium hydroxide, sorry, the ammonium hydroxide, we did sodium hydroxide. The ammonium hydroxide is blue, blue, and pink. This is yellow. This was blue. And we had red. Okay. Dish detergent was blue. Stayed blue. This was kind of a light pink. And here we had a yellow. We had green. And a pink. Isopropyl alcohol was red. This was blue. Turn blue. Yep. And then we had colorless. Colorless. Orange. This was blue and yellow. Okay. Distilled water, we had stayed red. This was stayed blue. Colorless. This was orange. Blue. And orange. The acetic acid, this would have been stayed red. This one turned red. This one, the acetic acid this is colorless. Then we have orange, yellow, and yellow. Here, the sodium bicarbonate, it was blue. This stayed blue here. And pink, orange, blue, and red. Okay? So, now that we have the results, what we're going to be able to do is we're going to be able to just kind of write down what we observe. We want to take what we observe and kind of draw some conclusions about these different indicators and about these different substances. Okay, so let's answer these questions here. Step 5, what we want to do is we want to determine if these are acidic, basic, or neutral. Okay, the best way to do that is to look at really the litmus paper. If it turns litmus paper, red litmus paper turns blue, then it's going to be basic. So this is basic. This is basic. Sorry, not writing very well there. Okay. This is basic. It's turning red, blue, and then this is basic. I'll just put a B there. Okay. If it turns blue litmus paper red, then it's acidic. I already have acidic there. And we have another acidic here. Okay, acid. These, you'll notice, didn't turn the red paper blue, nor did it turn the blue paper red. So these are neutral. I'll just put an N there for neutral. Those two are neutral. Okay, so acid, base, 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 neutral, neutral, acid, and base. Okay. Okay. Let's look at some of the questions. I'm going to skip ahead and look at some of the questions for the chart that we just did here. Okay? So the indicators, what I'd like you to do is I want you in question number 1, I want you to write down the different indicators that we used. Okay? So we use litmus paper, either red or blue. We use what's called phenolphthalein. It's kind of a funny spelling and a funny name. We use what is called phenol red. And we use methyl orange. And bromethymol blue. Okay. Now, what are the purpose of these indicators? Well, some indicators are very useful and they can help us to determine what is called the pH. The pH, so 1, it helps us determine the pH, and we'll talk about pH in class. It's just a number that tells you how specific or how acidic or basic something is. And 2, it could just tell you whether it is an acid or base, if you just want to be more general. Acid or base, or neutral. Okay. All right, now let's look at our table. So you can look back at your table if you want to. I'm going to refer to mine, but we're going to look at this table and determine some things, just answer some questions based upon the information that we have here. Okay? Let's see here. Oh. Okay. So the color that red litmus paper turned when you put it in an acid, it just stayed red. But for a base, it did turn the red litmus paper for a base turned it blue. Okay, so red litmus paper, if it turns blue, that's an indication you have a base. Okay, and if it was neutral, it just stayed red. It did not change colors at all. Okay, for blue litmus paper, if you put blue litmus paper in an acid, it's going to turn it red. So it can be the opposite color that the paper is. For base, it just stays blue, and neutral, it stays blue. Okay? Methyl orange, when you put this solution indicator in an acid, methyl orange, it turned it somewhat of a, let's see here. Yeah, it turned it somewhat of a reddish color, okay? Or maybe red-orange. All right? And for the base, it was more of a yellow-orange. Not a huge distinction between them, okay? And neutral was yellow-orange. So that one may not be as helpful when you're trying to distinguish between base and neutral, for example, okay? For phenolphthalein, if you put it in an acid, let me just look at an example here. It was colorless. Okay, acid was colorless. All right, so phenolphthalein, the acid was colorless. What about the base? The base, when we put phenolphthalein in the base, then we got a bit of a pink color. Okay, slight pink. It might have been a light pink or a little stronger pink. And then neutral was colorless. Okay. How about bromethymol blue? Bromethymol blue, if you look back at the results, in an acid, the bromethymol blue was yellow, and the base was blue. And neutral is blue. Okay. Number 8 says phenol red, acid was yellow, the base was red, and the neutral was orange. Okay, so you can see there's some of these are helpful to determine the difference between acid, base, or neutral. Some are not so helpful. So obviously your litmus paper can tell you right away whether it is an acid or a base. This indicator here, notice that you might be able to get a distinction between the acid and base. Acid's more red than the base is more yellow. Here, number 6, the phenolphthalein, is going to turn pink when it's a little bit more basic, okay, a little higher pH, whereas the acids and the neutral solutions are going to be colorless. Here, the bromethymol blue, you'll see a distinction between acid and base. Acid's yellow, base is blue. And for number 8 here, the phenol red, you get a nice little difference here in yellow, red, or orange, whether it's acid, base, or neutral. So we use these different indicators for different purposes to try to figure out what maybe the pH is, or determine if we have an acid or a base, or maybe if it's neutral or something like that. Okay? All right. Number 9 says, when testing substances with litmus paper, why must both a red and a blue piece of litmus paper be used? Well, because the red, for an acid, the blue turned red. But for a base, we had the red turned blue. So you have to use both in order to determine, okay, to verify that the substance is in fact either an acid or base, and it's not just neutral. Okay, if it's neutral, it'll just stay red. If it's red, the paper is red, and it'll just stay blue. So you have to use the other color to determine if it's going to turn that piece of paper the opposite color. Okay. All right, number 10 says give the common names for the following substances. I'm just going to give you these. Acetic acid, which we used in our lab, is actually just vinegar. You're familiar with vinegar. Sodium bicarbonate, the other word for that, the household word for that is baking soda. And isopropyl alcohol, that is also called rubbing alcohol. You probably have all of these in your house. Okay? All right, it says here, in solutions, a substance that releases hydronium or hydrogen ions, that is an acid. And we will talk about that in class. But anything that is going to release H plus ions, or actually when it's with water, it's H3O plus. These are the hydrogen ions. If those hydrogen ions join with water to actually make hydronium, this is hydronium here, hydronium. We'll talk about that in class. So if the H plus or the hydronium ions are prevalent in the solution, you're going to have an acid. If you get the hydroxide is OH negative, hydroxide ions, that's going to be a base. Okay? Okay, we're going to look at the second part, experiment 2 of this lab. And this time we're going to use what is called a universal indicator. As I mentioned to you, these indicators that we already used in part 1, they are going to turn colors, different colors based upon the pH. Well, what if we mixed all of those? If we mixed a lot of those indicators, then we might have a universal indicator that changes colors at every different range or grade of pH. Okay? If it's slightly acidic or really strong acidic or neutral or slightly basic or really strong basic, you're going to have different colors on all the different possibilities. So we're going to use what is called a universal indicator in this step here, in this experiment number 2. And I'm going to use the same 8 solutions, but I'm just going to put in a universal indicator piece of paper that's coated with a bunch of the different chemicals, and also in solution form. They're basically the same thing, but one is in paper form and one is in solution form. And then from that, we're going to refer to a chart and we're going to determine the pH of these different 8 solutions. Okay? So let me show you, I did this one as well, and so let me just show you the results. I'll share a photo with you of what happened, and then we'll talk about it. Okay, so let's write down what happened. With the paper, the universal indicator paper, let's write down the colors that we saw with each of these. This was red, this was blue, this was also blue, and this was kind of a green here. This was yellow, and the distilled water was kind of a yellow as well, maybe a little more greenish. The acetic acid was red, and this was a light blue or green, okay? Over here, the universal indicator solution, we had red, we had a kind of a violet or dark blue here. This was also a blue, this was green, this was yellow, this was a green. Here we had red, and then we had a blue. Okay. Now, with these different indicators, if the color is going to match up to a certain pH, and remember, pH is telling us how acidic or how basic it is. Okay. So if we're using the indicator paper, the indicator paper then comes with a little chart. Hopefully you can see that okay. That little chart is telling us then match the color to the number. The color to the number basically is going to tell you match the color to the pH number. Okay, and it's going to tell you how acidic or how basic it is. So let's go ahead and do that. Let's go ahead and match the color, and it would be the same for the solution as well. We could have a chart that shows you the different colors for the solution. If you have your litmus paper, or I should say your universal indicator, turning red, that is an indication that you have an acid, as we determined before. Okay, and it's a strong acid. The pH is probably around 1 or 2. Okay, sodium hydroxide is a base, as we indicated before. All right, and it's going to turn the universal indicator blue or kind of a violet, and it's going to have a strong base tendency to it, and the pH here is going to be probably greater than 10. Okay, so I would just put 10 plus, and that's true for the ammonium hydroxide as well, also a very strong base. Okay. The dish detergent. The dish detergent is somewhat neutral, so it has kind of a light green, so we're just going to say a pH of 7. Isopropyl alcohol is in that neutral region as well, so it's around a 6 or a 7 there. Okay. The distilled water also is a yellow kind of green, so that's going to be around a 7 as well. The acetic acid is red, definitely an acid, not as red as the hydrochloric acid up here, but still it was red, so we'll say around 3. Okay, and then the sodium bicarbonate was more of a blue, and we'll estimate that to be around an 8 or a 9. Okay, so just by comparing the color of the universal indicator to a chart, we then can determine what the pH is. Now notice, low pH is acidic, 1, 3, that's acidic. High pH, 10, 9 is basic. Okay, low pH is acidic. In fact, I'll let you know, an acid has a pH that is going to be less than 7, and a base has a pH that is greater than 7, and 7 is neutral. Okay. So let's answer the questions from this chart here. Using the second chart from the second experiment, let's see if we can answer some of these questions here. Okay. So the first one says substances which are acidic have a pH range of, oh, I just answered that, didn't I? So that's helpful. Let's talk about the pH range of acids here. So the pH range for acids, they go from basically 1 to 6, anything less than 7. So 1 to 6, depending on how strong of an acid it is. What's the concentration of the hydronium ions? basic, it's going to be from basically 8 to 14. That's the range for basic. Okay. The litmus paper and the universal indicator, they both determine the pH, so there's not really a strong difference, but one is just in paper form, one is a paper, and one is a solution. So you have a paper versus solution, but both of them basically do the same thing. And number 4, what range of colors do acidic substances turn? In other words, if it's a pH from 1 to 6, what colors can you expect? You're going to basically see reds, light reds, all the way up to maybe the orange range, reds and oranges. Okay, depending on dark red, light red, dark orange, light orange, something like that. That's for acidic. And then basic solutions are going to be blues and greens. All right, and the neutrals were kind of the yellow. All right, it says circle the substance in each pair, which is considered the strongest acid or base. So remember the pH range. The pH basically goes from 1 to 14. 1 is very acidic, strong acid. 14 is strong base. So if you have substance X, you don't know what it is, and the pH is 3, compared to substance Y, you don't know what that is, and its pH is 5, then which one is stronger acid? Here's your stronger acid. Okay, the stronger acid has the lower pH. Okay, and then let's put stronger acid. This is still an acid. The other one is still an acid. It's just a little bit weaker. Okay, and then substance A has a pH of 8 or a pH of 12. Well, the one that has a pH of 12 is the compared to the one that has just a pH of 8. All right? Okay, question number 7 says, which of the substances tested was the strongest acid? So if we look back at our chart, you'll see that the hydrochloric acid, I believe, was the strongest acid. So what does that tell us? It tells us that it releases a lot of hydronium ions, HCl. Okay, that's terrible, HCl. And the strongest base, I believe, was our sodium hydroxide. It releases a lot of hydroxide ions. There's the hydroxide ions. Okay, so for acids, you're going to see, a lot of times you'll see that H because it's going to release the H plus ion into the solution, which is going to combine with the water to make the hydronium ion. And then the base is going to release the hydroxide. You're going to see this OH negative here. Okay, basically it says give a textbook definition of pH. We'll talk about this in class, but pH is equal to the negative logarithm of the concentration of the hydronium ions. And this is how we write it. When it's put in brackets like there, that means concentration. Okay? All right, we're going to skip number 10. That's okay. All right, let's go ahead and finish this lab up by looking at the remaining questions that we need to do and some terms that we're going to refer to, and I'll help you with these as well. Okay? So turn to this page here, and you'll see that we have a number of different definitions, and all we're going to do is we're going to match those words, match the definitions to some words. Okay? Okay, so here are the answers that I'm going to share with you, and we'll look at each of these definitions and make sure you understand them. So a substance that contains hydrogen and releases those protons. The proton is basically the H+. That is called an acid. You can write down acid there. A substance which contains hydroxide ions, remember that's OH negative, that's going to be our base. Okay? Okay, an acid is going to release H+ ions, which is just a proton, into water, and that water is going to combine with the H plus to make hydronium ion. So that's called a hydronium ion right there, hydronium. And the OH negative is hydroxide ion, okay? Some acids are going to have two elements and oxygen. So if they have hydrogen, oxygen, and another element, that's called a ternary acid. If it just has two elements and it's an acid, it's called a binary. We already talked about indicators. Those are just different chemicals that detect the presence of acids and bases because of the color change. Litmus paper is going to turn red when you have it. The red is going to turn blue when it's a base, and the blue is going to turn red when it's an acid. Okay, again, it's just an indicator. Phenolphthalein is a type of indicator, and it turns pink. Neutralization is basically when you have an acid and a base that combine in order to form a neutral solution. It actually forms a salt and water, when we talk about that in class. This titration, I'll do a titration for you guys in class, and that is basically a method for mixing acids and bases and then determining what the concentration is of one of them that is unknown. Anhydride basically is when you are going to hydride is hydrogen, hydride, hydrogen, water, right? So you're going to remove water. pH, remember pH is going to indicate whether it's acidic or basic, and it ranges from 1 to 14. pH is, the calculation is actually the negative log of the concentration of the hydronium ions. A burette, that's just a long glass tube that we use for titration, and then a binary acid, remember, just has hydrogen and one other element. Okay, so there's some terms that you can just write down those words, and then let's finish this up, ladies and gentlemen, by answering the assessment questions that are here in order to indicate whether you understood the information in this lab. Okay, all right, the are the hydronium ions. The pH of a substance is a measure of both acidity and alkalinity. Alkalinity is another way to say base, a basic, okay? All right? So it measures both acidity and the alkalinity. In the presence of a base, pink litmus or red litmus paper will turn blue. And the chemical formula for hydrochloric acid is HCl. Bromothiamyl blue is the chemical which turns blank in an acid. Oh man, we got to look back at that, and let's double check to see. We'll look back at our table. In an acid, what does bromothiamyl blue do? Here it is. It is going to turn yellow. Looks like yellow. There's an acid right there turning yellow. Okay? Bromothiamyl blue is used as so it can be an indicator that is going to determine whether it's an acid or whether it's an alkaline, basic that means. Remember when some turned colors and it was a little more distinct, like you could tell between an acid and base there was a definite difference in the colors. Sometimes that's true for some indicators and sometimes that's not so true for other indicators. Okay? But bromothiamyl blue is used as an indicator, okay, in order to determine maybe where the pH is of certain solutions. The strength of an acid can be determined by a low reading. We have a low pH. Low pH is acidic, okay? So remember, if it's really, really low, the pH, it means it's a very strong acid. Number 8, a solution will be neutral if its pH is around 7. And hydroxide ion is OH negative. OH negative like that. There should actually be a little negative there too. Hydroxide ions have, there we go, have a negative charge. A -1 items would say, a -1 charge. Okay? This indicator turns pink in a base, and that is phenolphthalein. Phenolphthalein turned pink when the pH was around maybe 8. Okay, around 7 or 8. Okay. A few more. This indicator turns red in an acid. Okay, if we look back up at our table, red in an acid. So let's look back up here. Here's it. Red in an acid. It was the methyl orange. The methyl orange right there. Okay. Number 13, a substance turns pH paper light green. This substance is considered to be what? Well, if it's, remember, this is pH paper. If it's light green, it's not red or orange. It's not blue. It's kind of in the middle. So that's probably going to be a weak base. It's a little more blue than red. It's light green. It's going to be a weak base. All right. The correct formula for hydronium. Hydronium is the H3O+. This element is common to all acids. That's going to be the hydrogen. You're going to have hydrogen often in acids. When bases ionize, they release. A base is going to release the hydroxide, OH negative, hydroxide ions. If litmus paper is touched to a neutral substance, what will happen? Actually, it's not going to change colors. So basically, you're going to have your red stay red and your blue stays blue. So there's not going to be any change in your blue or red litmus paper. Number 18, as an acid becomes